Hey, good morning, Maya. Seth, how we doing today?
Good, how are you?
I'm doing pretty well. Seth put his two hands up there, and he's obviously doing pretty well. There you go. Good to see you guys. All right, let's bring everybody in here. All right. Good morning there, Mason, Tyler, Bella. Let's start by telling me about your weekend. Hey there. Let's go to the chat and why don't you tell me about your the last 7 days? I haven't seen you guys in a week. And we had a big 4-day weekend. So let's just break the ice and let me know how things are going. Tell me something good that happened over the weekend. I know I had the first really fun weekend I've had in 10 months. So I had a chance to go uh, with my wife out to, believe it or not, Lake Paris, and we did some camping and horseback riding out there, which was the first time we've actually got out of the house and did something fun over during this last 10 months. So tell me about your weekend, you guys. Go to the chat, give me a high and low of everything. It's good to see everybody. Let's turn our cameras on. Let's participate here. If you want to turn on your mic and just talk to me, that'd be great too. Love hearing your voices and everything. So give me a high and low in the chat, high point, low point, and tell me about your life, what's going on, what you did over the weekend. Let's just chat for a couple minutes while we bring everybody in the class. And as you do that, you guys, you can obviously get out your activity 7A1, get out all your notes, activities, everything, and some graph paper too by that, at that time. Got it, Bailey. Then you'll have to you'll have to probably watch the recording later on if that's the case. Understood. But thanks for telling me. I appreciate that. Tyler, let me see. You played football. Tyler, are you talking about like on a school team, or are you talking about just for fun with your buddies?
Just for fun with my friends.
Oh, just you went to the park and just did it old school?
Yeah.
I used to do that all the time, man. That was the best. Did you play flag or tackle?
We did
Two-hand touch.
and then it ended up being tackle at the end. So
well, boys will be boys, right? I that's awesome, man. I used to play a lot of sports in high school. I don't know if you guys know, but I was a quarterback on the football team. And then I was also on the soccer team, played varsity soccer for many years. Could have played in college. And so I played with some pretty talented people on the soccer team. And then I also played on the tennis team, varsity tennis team, and went to CIF there too. So, and I played with actually a couple pros on the tennis team. So my years at school, 84 and 85, were pretty remarkable. Guys on the tennis team and guys on the soccer team went pro. So we had some good years. So Ainsworth played a lot of sports during school, just so you know. Let's see. Maya slept in and watched movies. Oh, Maya, what was your favorite movie of the weekend?
Oh, I watched Heather's.
Was it any good?
Yeah, it was good.
All right. Very good. It's always good to kick in a movie once in a while or read a book or something like that. Alexis, got to break a chair with a pickaxe. Okay, now that is a new one. I have heard that. That's a new one. That's funny, Alexis. And then your low was you lost your phone in your house somewhere. Well, if you have an iPhone, use your Find iPhone app. I had to do that with my wife and to find her phone. And if you don't, maybe there's another app that you could use. But let me see. Myson, his high was running and the low was working on projects. Yep, a lot of projects going on. I understand that. Kennedy's high got a lot of rest. Very good. Low that I know, Kennedy, I know it ended. I know when we came back home we camped at Lake Paris this weekend. We brought the horses. We did a lot of horseback riding and it was beautiful and so much fun. I barbecued at night. We rode horses during the day and it was beautiful. And then finally on Monday night, I had to say, hey, baby, got to go home. She didn't want to go home. So Understand that totally. Bella, let me say hi. Was to have a real nice dinner with your boyfriend. Nice. And not feeling great and working too much. Yeah, you got to balance. So don't work too much. Bella, how many hours a week do you work on average?
Let's see. Probably like 25.
Okay, that's reasonable.
Yeah.
Don't go more than that because you got to balance work and school. And I've
Um,
talked to a couple other seniors that are working 30 plus, and I'm going, dude, that's just, you're in high school, man. You don't have to work. You got all the rest of your life to work your butt off. Okay. And so have balance, and focus on school. Okay.
no, I need money though.
Rest. I know you got to make some bucks, but just if you can't handle it, you got to back off somewhere, right? You can't back off school. You got to be successful in school. You're in school. Kylie's highways got to relax and lowest projects and homework. Yep. Ali, so I got your message about your camera. I understand that. But you got a good mindset, and the fact that you got a good mindset, Ali, and is just a good mindset and good attitude, and you're focusing on that. That's an important thing. So you got your mind focused on the right thing. Very good. Let me see. Bella Rogers, I got your message. Thank you. Seth. Seth, if you want, if you need some help with that, what you put in the chat, stick around at coming during the intervention today, and I will help you. How's that sound? Okay. Spencer went paintballing. Oh, Spencer, do you go to like the Pala, or where do you go? I know there's a big paintballing thing up north in Corona.
Yeah, there is, but we didn't go there. Me and my friends went over to, it's kind of near Carlsbad.
Okay. Did you win? Did your team win?
Oh yeah. We got we went against military people too. It was something.
Wow. I have real guns, but I don't have a paintball gun.
Paintball is fun. It's super fun. I used to do it. I did it a lot in Oklahoma since there was really nothing up to do there. And just getting it to doing it, just doing it here, it's a lot of fun.
But it costs a lot of money for all the equipment, so I got to figure out how to
Oh
do
yeah,
that.
it cost me like $350 for all the paintballing.
Oh
equipment.
yeah, and that's probably minimum. So, well, one of these days I'll do it.
Also, I got like big freaking welts from all the paintballs.
Oh yeah, especially if you get hit really close, that really hurts.
Yep.
Marianne got to relax over break, and then you have a big test on Thursday. Not in this class. So, what class do you have, Ken or Marianne? Big testing.
I have a big test for AP Gov tomorrow.
Oh, okay. Well, that's a big deal. You got to pass that. That's one of those courses you have to do well.
Yeah.
You have to pass and you have to do well. So good luck on that. Okay.
Yeah.
So then let me see. Berkeley went to Utah. Berkeley, what'd you do in Utah?
I was looking at a campus there. I was looking at SUU because I got accepted there, and then
Nice.
I wanted to see the snow, so we also looked at the snow too, which was super fun.
Yeah. So did you make a decision?
Oh no, not yet. I still need to tour like all the schools like in California and then my one school in Oregon.
Very good. Well, let me know when you decide. All right. And you have a test today as well. What do you have a test in?
I have a test in human anatomy, I believe.
Holy cow.
I just kind of go with the flow now.
Is that difficult?
And no, I'll be fine.
Good. All right. Well, thanks for you guys let me know about everything. Let's get started. Have graph paper, and then also take out all your notes and activities and put them off to the side so you can access them. And then Matthew and Courtney, you need to put your cameras on. I heard from Ali and Bella why. They had valid reasons, but if you're going to participate with me, put your cameras on, and so I can see you, look at you. I can see your, give physical feedback. I can help you, yada, yada. So just one of those things. It's much better when we can interact that way. So I doubt you guys would like the Zoom experience if I had my camera off and my sound off. Would that be good or bad if I turn my sound off and my video off? Good or
Also,
bad,
it wouldn't
guys?
be much of a class.
I know, right? And so when my students don't participate with their cameras and their voices in the chat, it sucks. I have some classes are really good at that. You guys are really good at the chat, and right now you're really pretty good at the videos too, the cameras. And when you guys participate like that, it makes it more enjoyable for me. It makes it more enjoyable for everyone else in the class. I mean, it's just better all around when we could see each other, talk to one another, and communicate effectively. And Kaylee, I see you shaking your head. You're agreeing. Yeah, I really feel that. And I think that this semester, because I stepped up the protocol and got you guys to participate in multiple ways, I don't know about you guys, but I think the sessions have been going better than, in the prior days, in the beginning days when we were getting used to this crazy online stuff. Okay, we're going to practice concepts from A1 and A2. Do this on graph paper if you have it. If you don't, then just do the best you can. And I'm just going to take concepts and let's see what you guys have learned through the last few activities in 7A1 and in 7A2. And by the way, just so you know, I haven't finished grading all the homework that has been turned in, but let me just say this, that there are way too many people that are falling way behind real quick. And I'll be quizzing on 7A1, 7A2, and 7A3 at the end of the week. And not only that, if you don't stay up with me and do the prep videos, then you're going to be lost in class. And especially coming up, and 7A3 is not easy. So when I say do a prep video to get prepared, prep is getting prepared. That's what it means. And then it's really important for you guys because you come in cold, you're not gonna do so well, and you're gonna have a bad experience. And you don't want that. You want to be prepared. So you got to watch the videos, and because we're online, and that's what we got to do. And by the way, I spent a lot of time. I spent 6 hours yesterday preparing videos for you guys and for my other class called Financial Algebra. It takes a lot of time and effort on my part to get everything ready for you. And so I do my part, but I need everybody to step up to the plate and make sure you guys do your part. And if you guys do that, you'll be successful. Okay. All right. So we're going to start off with a couple definitions, because if you don't know what domain and range means, then you can't do anything in respect to our activities right now. So let's start off with the definition of domain. Okay. So let's see who's been learning something in the last couple of activities here. So is domain the input or the output of a function?
It's the input.
That's right. It's the input. And typically, if we're using y in terms of x, it's the input of the x variables, but it's basically the input of a function. So that's key concept, and it's all possible x values, all possible values or x values of the function. If we're using x as our variable, which we're not always using, but it's all possible x values basically. If we're using x and y as our variable base. Not always happening, but we do use other variables, especially if you're in physics. If you guys are taking physics, they use all kinds of crazy variables, or chemistry too. And then the range, okay, is the output, what you get out of the function. And you know that you obviously put a value into the function called the input. So x is typically the input variable, and y is the output variable. And it represents all possible y values, all possible y values. You need to know some basic concepts like that. So I'm going to start off the lesson today with some graphs, and I'm going to ask you to determine the range, the domain and the range. That's why I asked you guys to take graph paper out. But if you don't have it, just sketch with me. All right, so let's draw a coordinate plane and let's do some sketching. I'm going to have you guys plot points and everything, so try to be accurate so that your graph that you're drawing on your paper is the same as mine. Okay, and the first goal is to determine the range, the domain and the range of the functions. And we're going to write it in words, symbols, interval notation, everything that I've been discussing in my videos. So let's plot A at 2, 3. So go right 2, up 3 and plot A. And that's at 2, 3. And let's plot B at 6, 7. So go right 6. up 7. Okay, so B is at 6 comma 7, and then connect them. So we form this line segment. So everybody sketch the same picture. And again, if you don't have graph paper, no big deal. Just draw good sketches, okay? So the first goal is I'm going to give you a variety of different graphs. They're all going to be different. And the whole goal right now is to determine the domain and the range. And we're obviously going to do one at a time because we're going to use the chat for your responses. Unless you want to use your mic, you can offer your opinion and verbally too as well. So D for domain, or let's just write out domain. So be clear here. Okay, so what do you think the domain is? Before I say anything, I want you guys to give it a shot here. Let's see what you guys have learned. And then if you have questions, I want you to speak up. This stuff's abstract. And so don't hesitate to speak up. And if I ask your opinion, you're not sure, then be honest with me and say not sure, okay? And when I hear things like that, I usually explain things in detail. All right, everybody go to the chat or turn on your mics. Let me know. What are you guys thinking about the domain? Let's do one at a time. Domain first. What are you guys thinking?
In the sense that it doesn't go on forever.
That's true, but you got to be specific about the domain. So you have to tell me exactly what the set of all possible X values is for the domain.
Oh, okay, yeah. Then
you could do it in words, symbols, or interval notation.
I agree with the chat, and they're all saying close parentheses 2 comma 6, and
so
continuing with the close.
Yeah, so
I
all
agree with chat.
reals. Okay, so all reals from 2 to 6 closed. Okay, so let's make sure that you guys understand that when you talk about the domain, you project down to the x-axis, and the smallest x value is 2 at point A, and the largest x value, if you go down to the x value, is 6. Look at the x coordinates there. So all the points on the graph, the minimum x value is 2. We'll call that x min. The biggest x value, we'll call it x max, is 6. And you're right, you guys, you write it the closed interval from 2 to 6. Or you can say all reals from 2 to 6 inclusively. Inclusively meaning that you're including the endpoints 2 and 6. Okay, or if you want to write it in interval notation, you go 2 less than or equal to x less than or equal to 6. So either way, using interval notation or inequalities, they mean the same thing. And I would suggest that you write it down both ways, because sometimes I use inequalities and sometimes I use intervals. So you have to understand both. Okay, so all reals from 2 to 6. Okay, basically. Okay, the range is different. Let's switch concepts. What do you guys see for the set of all possible y values? And when you see comments in the chat, you can either say agree, disagree, not sure. And if, you know, again, you want to be honest with me here, because if you're not sure, ask questions. There's a way to look at the graph to determine what the range is. Okay. Okay, so you guys are saying all reals from 3 to 7 inclusively, meaning closed. So the way you do that is you look at the y-axis. So at point A, the y value, the minimum y value, y minimum, which is the smallest y value on the graph, is 3, and the maximum y value is 7. We'll call that y max is 7. So the range is looked at vertically. The domain is looked at horizontally. Key concept right there, guys. You got to train your eyes to look horizontally on the x-axis for the domain, left and right. And then when I say range, when I switch concepts to range, you got to think vertically, min and max. If there is a min and if there is max. Sometimes there's no max. Sometimes it goes to infinity. All right, so range, domain, look left to right. Range, look up and down, okay? And that will give you your range. And so the range here is from 3 to 7 inclusively. And when I say inclusively, this is a closed interval. Okay, so 3 less than or equal to y less than or equal to 7. That's how you write it using inequalities. So you need this is called interval notation here on the left, interval notation. And on the right are called inequalities. And they're equivalent. It's just a different way to say the same thing. And you need to get familiar with the inequalities because coming up in 7A3, all the domains are in inequalities. So in the beginning, in 7A1 and 7A2, we did a lot of interval notation. And then we transitioned back and forth between the notations because in higher mathematics from pre-calc on up, because this is a pre-calc class, on up, they go back and forth and they use both of these. Okie dokie. Now you guys speak up if you have questions. I want to give you a variety of examples right now, and I'm looking at your activities. I'm going to take out examples that I think represent the concepts in that activity. So let's draw a new graph. Okay, so set up a new coordinate plane. And just sketch with me. And each one's going to be different. So it has different attributes. So let's graph 4,2. By the way, is this graph big enough for you guys to see on your screen? Give me a thumbs up if it is, or thumbs down if not. Okay, I just want to make sure that you guys can see it pretty well. Okay, thank you. Okay, so let's graph 4,2 and let's do this. So this is your function f of x. We'll start with domain. What do you guys see? This one's different now. What do you think the domain is here? The set of all possible x values. Let me know when you're ready. You can say it in words. You can use inequalities. You can use words, and you could use intervals. William, how you doing? Good to see you. Get some graph paper out and join us right here, okay? And then put your activities 7A1 and A2. Just have all your notes on the side, and just we're practicing right now concepts from 7A1 and 7A2. Okay, so let's look here. You guys are responding now. So you guys all agree. How about that? Okay, so you're saying all reals greater than or equal to 4. From 4 to infinity is all reals greater than or equal to 4. So I agree with that. So you project down to the x-axis, go down here. The smallest x value, x minimum, is 4. So it's going to be 4 to infinity. Or in words, all reals greater than or equal to 4. Or you can say x greater than or equal to 4 that way as well. All mean the same thing. No problem, William. Okay, let's keep practicing here. Switch to range. Tell me what you see. And again, don't practice with me here. Ask questions. Be honest with yourself and me. And if you're not understanding this, speak up. So Berkeley says 2 to infinity. What do you guys think? I see you, Kaylee, Kennedy, Alexis. Okay. All right. So, and Marianne too. So on the range, you go to the y-axis. Okay. Y-axis, and the smallest y value is 2, and it goes up forever to positive infinity up top. It never stops, increasing to the upper right. So the y values get higher and higher and higher to positive infinity. So the range here is closed at 2 to infinity. So all reals greater than or equal to 2. So all reals greater than or equal to 2, or you can say y is greater than or equal to 2. Okay, now let me give you this one here. So let's draw a new graph. So William, can you just screenshot that right there so you can catch up with us? Let me know when you're good. Okay. Okay, so on this one here, this one's going to be a little different. I want you guys to plot the following points. I want you to go up 3. So at 0, 3, this is point A. At 0, 3, B is at 3, 0. And then C is at 0, -3. Plot those 3 points and draw a semicircle. Best you can. And let's talk domain and range. So functions, this is f of x now, can look basically like anything. So you need to get a wide experience of all the different type of graphs that are possible and train your eyes to look to determine the domain and the range. So let's start off with the domain. What are the set of all possible x values? Sometimes there's a min and max, sometimes there's not. It depends on the function. So what are all the possible x values on this function? That's the domain. Tell me what you see. Okay, everybody take a look at the chat here. So, okay, so everybody's saying from 0 to 3 closed. All reals from 0 to 3. I agree with that. Okay, so let me enlarge this. So the smallest x value is at point A, and that is x minimum. And the biggest x value is at point B, and that's x max. And then all the other values, all the other x values on the graph are between 0 and 3. So you guys are correct. It's the closed interval from 0 to 3. That's how you say it. Closed interval from 0 to 3. Or you can say all reals from 0 to 3 inclusively. The word inclusively means that you're including the endpoints. So you're talking about a closed interval. Okay, how about the range? Range is different. What do you guys see? What do you guys think about what Kennedy said? So it closed interval from -3 to 3. So the highest point on the graph would be y max. So this point right here at 3 is y max. Looking at the y-axis, the low point on the graph is at -3, y minimum. So this does have a min and max. So I got it, Vanessa. I agree with you guys from -3 to 3. Closed. Okay, now let me change it up. Last year in, well, in Algebra 1, you talked about asymptotes, but last year in Algebra 2, you should have talked a lot about it. So let me introduce the asymptote. So let's draw a new graph. And I want you to This is the x-axis, y-axis, and shift over 3 units and draw this dotted line at x equals 3. It's called an asymptote. Let's start off with that. A lot of graphs, a lot of functions, log functions, rational functions, a lot of different functions have asymptotes when you graph them. These imaginary lines that the function approaches and gets infinitely close. So watch this. I'm going to draw a function here. And so sketch this function. So what you see in green is our function f of x. So let's find the domain and range of this guy. So what do you think the set of all possible x values here? Does this have an x minimum? Does it have a max? Is it restricted? What do you guys see?
I have a question. Is it touching x equals 3? Like, does it ever touch 3 or does it just go right before it?
That is a great question. Okay. And my answer is we call it asymptotic. So here's my vertical line, Kaylee, and the function gets infinitely close to that. It gets closer and closer and closer and closer and closer, but it doesn't pass it.
It doesn't?
So-
Okay.
No. So we call that asymptotic. It goes up really, really close, gets closer, 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 and it gets infinitely close, meaning so close that you can't even distinguish the two, but it never touches.
Okay.
That's a
Thank
great
you.
question. So what do you guys think on the domain here? So Shane said from negative infinity to 3. Berkeley said 3 to infinity. That means greater than 3, Berkeley, just so you know. And then what Shane said means all reals less than 3. So you got to be thinking where these x values on the graph, like if you pick any point on the graph, like at point A, the x value's got to be negative because it's left of 0. At point B, I'm just picking points here. Point B, the x value is negative. You know, it's between -3 and -4. And all these x values, they can be negative. They could be 0 right on the y-axis, or they could be positive. All right, but you got to describe all these x values here. All of these x values. Where are they in relationship to 3? 3 is your focus point. Everybody give me your opinion. We have different responses up there. So what do you guys see? Where are all the x values on the green curve in respect to 3? How do you describe them since they're to the left of 3? Because that curve is to the left, not to the right. Okay, Tyler and Destiny, write that using inequalities. Using the words either less than or equal to or greater than or equal to. What would that be? So less than, strictly less than, or like you have a keyboard, you know where the less than symbol is? So how do you write that? There you go. So that's it. Now, how do you write that as an interval? How do you write all reals less than 3 as an interval? So I agree with it. This is using inequalities. That is correct. X is all reals less than 3. There we go. All right. So you can also write it as an interval from -infinity to 3 open. So at the top is called an inequality, and using the parentheses is called interval notation. Or you can say all reals less than 3. All reals. All right, less than 3. Very good. Okay, now let's switch. Range. Range is different. Make sure you write down everything. You guys need to be able to interpret mentally it in words and in symbols. You got to be able to go back and forth in your mind. Now the range is totally different. What do you guys see for the y values? Now think y values. Where are all the y values? You got to describe them. Points on the function. Notice that the function, I'll give you a big hint here, the function is above the x-axis.
I've got a question.
Yep.
So, is 0 like a horizontal asymptote? I'm
Yeah,
sorry, I
well,
can't
the
speak.
x-axis is, yes.
Yeah.
So there's two asymptotes. There's the x-axis is one as well. So asymptote here and asymptote here. It's called y equals 0. That's the equation of it. If you type y equals 0 in Desmos, you get the x-axis right there. And that's an important question, Tristan, because you need to know that to describe the range. Because if you know that the x-axis is an asymptote, that means the function never touches it. That means the function can never be equal, or the y values can never be equal to 0. So what you brought up was like important. So I see a couple, well, there are only 2 responses. Shane said from 0 to infinity. Marianne agrees. What do you guys think? I've got like 30 people in here, 31. Yeah, there you go. You can give me physical responses. Thank you, Kaylee. A few others. All right, so all the y values are above the y-axis. So all the y values have to be above or greater than 0. So all reals greater than or equal to 0. And the way you write that in inequalities is like this: y greater than or equal to 0. Excuse me, that's incorrect. I said it wrong. Correct me, guys. Correct me here. Not greater than or equal to 0, but what?
All real is just greater than 0.
Very good. Okay, Ainsworth made a little goof right there. All reals greater than 0 because you can't touch the asymptote. And then using the interval notation, you go open at 0 to positive infinity, as Shane mentioned up there in the chat. Okay. Okay, so let me see here. So we did a few already. Which one did I need to do? So, okay, one more. Okay, now this one's different. So let's draw a new graph. Okay, so let's all draw the same graph here. So let's plot the following points. So plot the first point at -2, 3. So A is at -2, 3. Plot B at 4, 3. So that we all have the same graph, and just connect them. So now this is your function f of x. Your function could look in many different forms, as you're finding out right now. I can design the function any way I want. So that's why I'm giving you a variety here. So let's say you have this graph of the function here, and we want to determine what the domain is. It's a set of all possible x values. Sometimes the domain has an x minimum. Sometimes it has an x max. Sometimes it doesn't. So you have to describe the domain, which is a set of all possible x values, in different ways. So what do you guys see? Let me know when you're ready. When I ask you about the domain, you got to be thinking all possible x values. That's what you got to be thinking in your head. Oh, you know what? Well, no, I don't want to change it. So, okay, so here we go. So you guys are saying all reals from -2 to 4. Okay, so the x-axis is horizontal. So you project down here to -2, project down here to 4, and the domain is right here looking at the x-axis from -2 to 4. So I agree with that. The range is totally different. So what do you guys see for the range?
Three. Could you just write 3? Because it doesn't change.
What's the word for that? If things don't change, what do you
It's
call it?
constant.
That's right. This is the constant function. And
But
so,
could you just write 3?
yeah, you say y equals 3. So Kennedy, you're thinking the same thing as Tristan. So when things don't change, you just say y equals 3 because it's constant. So you just say y equals 3. It's constant function. Constant. It doesn't change. It's a horizontal. All horizontal functions are like that. Okay. So good going. All right. Now let's take a look at what we've done so far. We've talked about the domain and range for a variety of different graphs. So what I want to do now is switch to the function. This is more abstract. Okay. Okay. So let's write this down. Find the domain of each function. Now, I'm not going to give you a graph. I'm going to give you the function. Now, I want you guys to look at your 7A2 prep. So open up your notes right now to 7A2 prep and the discussion that I had before I launched the activity that you guys worked on. So on that right there, that's and you can in 7A2 prep, I discussed a variety of different examples. This is on page 8 in your notes. So go to page 8. I'm looking at my notes right here, 7A2 prep discussion. And in that I discussed 6 functions, and I'm going to test your understanding right now on that. So here we go. So I'm trying to teach you also to use your notes, because you take notes, you go to the prep videos for a reason. So everything's open note from our discussions to the quizzes and the tests. So learn how to use your notes effectively. Okay, so I'm referring to 7A2 prep here. Okay, my first one, f of x is equal to 3x minus 2. Question is what's the domain? Okay, so let me ask you a basic question first, which everybody should be able to answer, because this goes back to algebra 1. Okay, what kind of function is that? 3x minus 2. What's the most famous type of function that you first started learning in algebra? What is it called? What's the name
Linear.
of that? There we go. There we go. It's called a linear function, and it's in slope-intercept form. That's Shane. That's what you're getting. That's what you're referring to. So yeah, it's the famous y equals mx plus b. It's called a linear function. And it's important to recognize that. So you should know what the domain is automatically without even looking at the graph. What did I say in my prep videos for all linear functions? What's the domain for all linear functions? When I say all, that's a big word, guys.
All real numbers,
Yeah. Do you know why?
because it never ends.
That's one reason. What else?
And
It has no
it's-
restrictions.
Say it again.
It has no restrictions.
That's right. And there's no holes, no asymptotes, no restrictions. It's a set of all reals, and you could write it from negative infinity to infinity, or you can say all reals. I'll write it both ways. So in words, you say all reals. Using integral notation, you go from negative infinity to infinity. Okay, I'm not going to ask you what the range is yet. So let's just do domain questions right now. Domain. Okay, number 2. And again, look at your notes here. I'm just going to pick a variety of different functions. in there. So f of x is equal to 5 divided by 4x minus 1. What kind of function is that? In the video, I described like 6 different families of functions. The first family of functions was linear. What is this? What is it called? What kind of function is it?
Is it the rational?
That's right. Rational, fractional, yes. Okay, and what did I say about all rational functions?
All are real except like usually one number, maybe.
Okay, yeah, they have restrictions. Very good. Okay, so all rational functions have restrictions. Okay, boom, exclamation point. So that tells you that the domain is all reals except something. All reals except blank, okay? So how do you determine that? So look at your notes. How did I approach that in the lesson? You could look at number 3 in the prep. Yeah, look at number 3.
It can't be equal to 0.
What can't be equal to 0?
The x.
Not x, but what? X can be 0 sometimes, so don't worry about that. What
Oh.
can't be 0?
The denominator.
That's right. So this right here, this cannot be equal to 0. Why is that?
It'll become undefined.
That's right. You cannot divide by 0. So 5 divided by 0 is undefined. That's why. So you cannot divide by 0. So for what value of x makes that 0? How in the world did you get that, Tristan?
Well, 1/4 of 4 is 1. And 1 minus 1 is 0.
Guys, hopefully you guys just listen to that right there, because he's using what's called number sense. And that is beautiful. Okay, give me a high five, Tristan. Boom. Okay, now listen. The way I did in the video is I said, okay, 4x minus 1 cannot be equal to 0. We know that. You can't divide by 0. So if you didn't use number sense like he did, you can solve it. So let's solve this equation. What's first step? It's a 2-step equation. Think basic. Talk to me, guys. How do we solve that, baby?
All reals except 1/4.
Well, I know, but how do you solve it, Shane?
Oh, add
Stepwise.
1.
Okay.
Add 1 to both sides. Yeah.
Okay.
And then divide 4 on each side.
There you go. Okay, and so all reals except 1/4. Okay, or you can, in symbols, it looks like this. Okay, and that is the domain, all reals except 1/4, because as Tristan said earlier, 4 times 1/4 is 1, and 1 minus 1 is 0, and that would be an undefined situation. Okay, because you cannot divide by 0, man. No way. You never could, and never will be. I still haven't done it, been able to do it after 53 years. Okay. I doubt I'll be able to in my lifetime. All right, number 3. Here's here's a square root function. Okay, so f of x is equal to the square root of 2x minus 5. This is called a square root function. And what did you guys learn about this one in my lesson, my video? Square root functions, do they have restrictions or do they not? What do you guys remember? Look at your notes.
They always have restrictions.
That's right.
Because-
All square root functions have restrictions. So the question is what's the restriction? So all square root functions have restrictions. So the question is what's the restriction? So how do we determine this one? Look at your notes. How do we approach this? Because you guys, you can't square root a negative because you'll get a complex number. And so when you're graphing these functions, you can only graph real numbers, not complex on the real plane. So this right here, this expression in the inside the radical, okay, it's called a radicand. This 2x minus 5, whatever it is, it cannot be negative. So how do you
It
approach
also
this?
can't be equal to 0.
Oh, sure it can.
It can?
Yeah, you can square root 0. You know what square root of 0 is?
0.
Right. So it could be 0, but it can't be negative. It could be 0 or positive, but it can't be negative. Because if you square root a negative, you get a complex number, and we can't graph that on the real plane. We'd have to switch to the complex plane, which we don't want to do right now. When you graph a function in Desmos, we graph real numbers only, not complex. So how do we approach this? Look at your notes, guys. How do we approach it? How'd you get that?
Using that number sense you were talking about. If you take 2 times 2.5, you get 5, and 5 minus 5 is 0. And so you said that 0 can be graphed, but nothing less than 0 can. So like, it just can't be less than 2.5.
Okay, now what do you do if you can't use the number sense like he's using? Because some people are good at that, like he is.
Another thing that you can do is you can just like, if like referring to the radicand as you called it, as like mx plus b, do the inverse of b and then divide it by the m, I guess you could say, if there is one. Oh,
You guys got his remind right.
no, I didn't.
Oh, his computer froze.
Oh. Usually takes like a few minutes for him to get back though.
Okay, I'm back. So I gotta tell you something funny. So everybody turn your cameras back on. So when my computer froze, as I told you I sent out a message on Remind, and some of you guys were yawning at the time my computer froze. Kennedy, you were one of them, and you had this big yawn, and then my computer froze, and then it was awesome. It was awesome. I loved it. So anyways, I'm back. I just want to tell you something funny right there. But let's finish up here. We have a couple more examples to do, and just so that we have a wide variety of everything, and make sure you guys feel comfortable with it. So we were talking about this right here, and we're talking about number sense, if I remember correctly. But I asked you guys, how do we approach this algebraically? We didn't get to finish that, so I need you guys' help. If this expression 2x minus 5 cannot be negative, how do you approach it algebraically? Put your thinking caps on. I need your help, guys.
Would you do 2x minus 5 is greater than or equal to 0, and then do that like as an equation?
Yes, very good. Good thought. So if it can't be negative, that means it's got to be greater than or equal to 0. So you say, okay, this is the domain now. The 2x minus 5 has to be greater than or equal to 0. And then if you solve this, we're going to get the value that Tristan came up with earlier. Okay, using a little bit of number sense right there. And Marianne, you're right on in the chat. Okay, so good job there. So let's add 5. To solve the inequality, you get 2x greater than or equal to 5. Obviously divide by 2, and you get all reals greater than or equal to 5 halves, which is the same thing as 2.5. So all reals greater than 2.5. Now, once you get that algebraically, what do you have at your disposal? What tool do you have to check this? What tool does everybody have available to check this?
Desmos.
That's right. So write that down. So you need to know how to use Desmos really well. So let's graph this. Here we go. Go open up Desmos and do what I'm doing. And then when you open up Desmos, these graphs right here automatically pop up. So just X them out, clear them out. Because obviously we want to enter in this function here. Y is equal to, just type it in, y, f of x is the same thing as y is equal to the square root, and you just type in 2x minus 5. Very simple. Now look at this, here's the graph. Now watch this. What's cool about Desmos is that you can trace along the function. So if you're doing this with me right now, put your cursor on the graph and do what I'm doing. It's called tracing the function. And everybody go to the leftmost point and tap on it. And you'll see that the leftmost point, the minimum x value is 2.5, which we talked about earlier. Okay, 2.5 is the smallest x value. And then if you go to the right, x values get bigger and bigger and bigger to infinity. So it's all reals greater than or equal to 2.5, or the closed interval from 2.5 to infinity. Give me a thumbs up if that makes sense. Okay, so let's write it in words. So we say all reals, okay, greater than or equal to 2.5. Or you can say 2.5 closed to infinity open, okay, using the interval notation. So you have a tool called Desmos that it's probably the easiest graphing program I've ever used. It's easier than the TID4 or any of the graphing calculators that you can buy, and it's free. And I use it exclusively in this class because it's free to everybody, and not everybody has a TID4. So if you learn how to use this, which you can download free on your phone, by the way, I have it on my phone, my iPad. If we were in class, what I've done in the past, like last year, prior to March 13th, I've had everybody take out their phones and iPads. We all download it, and we use Desmos in class all the time. And we use it to verify and learn from and everything. So it's kind of nice. Okay, one last function. So And then I will talk about what you guys need to do to get ready for Friday, because you have a big day on Friday. So we started talking about linear functions. Then I went to rational functions. And then I went to square root functions. Well, the last one I need to talk about today, and this will culminate our lesson today, is the log functions. Now, if you're looking at your prep, it's the last one, number 6. So use your notes and look at number 6 in your notes. Okay, so let me design a function here, y or f of x. Again, you remember, when I say f of x, that's a y variable. It's the same thing. And let's suppose that we have it equal to the log of x minus 9. So log of x minus 9. So this expression inside the log is called the argument. It's the argument of the log. That's what they call it. So in the video, I talked about what a very important aspect on the domain. And I talked about what the argument, I don't want to give it away, what the argument has to be, well, it's restricted. Let's just put it that way, because I don't want to give it away. The argument, the domain, this is the domain right here. Well, you have to look in here. The input is the domain, is restricted. All log functions have restricted domains. All log functions have restricted domains. So read your notes. What did I say? So Kaylee says the argument has to be greater than 0. Not x, but the argument. So you can say argument greater than 0, but you're on the right track, okay? So this argument right here, this, let me erase this. This right here, the argument, whatever it may be, has to be positive. It has to be greater than 0, positive only. And when I say positive, that doesn't include 0. 0 is neutral. It's not negative. 0 is not negative. It's not positive. It's neutral. It's right in between the negatives and the positives. So when someone says positive only, they mean greater than 0, not greater than or equal to 0. They mean greater than 0. So based upon that right there, what is the domain? What do you guys see for the domain based upon what I just said? Because that's all you need to know. Be more specific, Marianne. Put that to the chat, Destiny. I mean, put that to everybody. That's what I meant. So what Destiny said and what Shane said is the same thing. Okay, all reals greater than 9 or from 9 to infinity. They don't include 9 though. The domain does not include 9. Because 9 minus 9 is 0. Oh, by the way, let me show you something here. Watch this. I'm going to go to the other Desmos scientific calculator. Watch what happens. I go function and I select log, function, log, and if I put it in 0, watch what happens. Look at this calculator, guys. Log of 0 is undefined. And I'm not going to get into all the reasoning behind that, but logs are not defined at 0. Not x equals 0, but they're not defined at 0. So when I say that, you have to be thinking, you know, what would make x minus 9 0? And then x restricted. And from what Shane, Destiny, and Marianne said up there, x minus 9 has to be greater than 0. Not x, but x minus 9, the entire argument. Okay, and then when you solve this guy, you get all real numbers greater than 9, like 9.1 or 9.2 or 9.3 or anything bigger than 9. But not 9, because 9 minus 9 is 0, and the log of 0 is undefined, as I just showed you. Okay, so let's write a little note here, okay? Log of 0 is undefined. Okay, you can try it on any calculator. You're not going to get a value. Okay, so all reals greater than 9 or from 9 to infinity, open. So there's the domain there. So I really did a lot with you guys in this hour today. We've been together an hour and 5 minutes. I mean, we did a lot. If you go back to the very beginning, look at this. We discussed how to determine the domain and the range for a variety of different situations. Okay, they're extremely different. I gave you a good variety of all the different possibilities. And then I transitioned to functions, which is a more abstract concept. And so if you did not complete 7A1 or 7A2, which is the case, a lot of seniors are way behind right now. You have to set a goal to finish by tonight, because I'm getting you started on 7A3 tonight. So let's go to Canvas, and I want to show you how to get ready for 7A3 activity, which is going to be done during class on Friday. There's a couple things you have to do. And get your calendar out, and let's write a few things down on your calendar. You guys should learn the calendaring skill. You got to keep track of all your 6 classes and your work and your family life, and oh my God, all the stuff. Okay, now take an eye on Canvas here. Notice that 7A3, Prep 1 and Prep 2 for parts 1 and 2 are up there. Okay, so I'm not having you submit the activity until Friday, until we're done, okay, until we meet again. I want you guys to go through the 2 prep videos. There's Prep 1 and Prep 2. So I'm going to open them up and show you. And again, make notes on your calendar for what you have to do tonight or tomorrow night. If you guys have a test tonight, like Berkeley, you have a test tonight or today. Oh, well, you're going to be done today. So you have a test next period. Is that what you said? Okay. So you can still do this tonight if you choose to. Okay, so 7A3 Prep 1 is for part 1 of the activity. The activity is broken up to 2 parts. So I broke my preps into 2 parts because they're different. Okay, and we're talking about piecewise functions here. It's going to get technical on piecewise functions. This has to be done either tonight or tomorrow night, but it has to be done prior to Friday. You come in cold, God help you. God help you. So this has to be done either tonight or tomorrow night. I would split it up because you're going to have to watch 2 preps. Okay, two prep videos. This is where you submit your activity and write a little note. You are not doing 7A3 activity right now. Not today, not tomorrow. You're waiting until Friday. And I'm talking about this. Let me go to 7A3 right now and we'll write down Friday on it. Here's 7A3. Okay, in the beginning, this is my discussion right here. Everybody go to page 10 in your notes and write this down. This is 7A3 prep number 1. Okay, it's on page 10 as you see. Okay, I discussed this example on piecewise functions, and I discussed examples 1, 2, and 3. We're skipping this one. You'll see that done in the video. We're skipping 4 because I'm not going to give you any trig functions yet. This is on page 11. You're going to go all through this in the prep video. Your activity follows. This activity is on page 12. This is Friday. You do not do this until then. Okay, you wait till you go through the 2 videos because this is a little technical. And from when I talked to my students from last year, they all told me that this is not the easiest lesson in the world. So I designed a couple additional videos for you guys, separated into 2 parts, part 1 and part 2, because the parts are different. This is part 1 here. Write this down. Number 1, parts A, B, C, and D. That's all part 1. And then on the next page is part 2. So you need to watch the 2 preps, prep 1 video and prep 2 video, because as you can tell in part 2, it's different. You have to write the function from the graph, and that's harder. At least that's what everybody told me last year. Okay, so I'm going to make another video for this right here for part 2. And then when you come into class, we're going to do the activity in class. So the activity, you wait for the activity on Friday. The only thing that you need to do at home are the preps. So if you go, let's go back into Canvas real quick. Here's prep 2. Notice there's no video link in there yet because I'm not done producing it. I have to finish that today. I got prep 1 video. It's already in. I did that yesterday. I've got to do this one today. Each video takes 1 to 3 hours for me. Okay, so it takes time. So I will get that in by tonight. So what I suggest you guys do, go ahead and jump in if you have a question, Tristan.
Yeah, so we do pages 10 and 11, correct? Minus number 4 on page 11.
Yeah, just the discussion examples, not the activity that's itself.
Okay.
The activity itself, you wait till Friday, but the where it says 7A3, here, let me show you again. This part right here. So on page 10, there, it says discussion right here. In the video, I discussed that one and I continue it right here. This is 7A3 continued. I discuss examples 1, 2, and 3. I'm going to skip 4 because I'm not going to throw a trig at you right now. Okay. Does that make sense, you guys? Okay. And then the second prep, well, that's on the next page. And that I will finish developing today. Okay. Any other questions or needs before I let you guys go have lunch? Take a break. We need a stretch break. We probably need to eat. Any questions or needs? Okay, I thought you did great today. Good job. I'm proud of you guys. Leave me with big smiles here, and I'll see you in 2 days, unless you call me or message me and want to meet up with me. But other than that, I'll see you on Friday. You guys
Bye,
have
Mr. Ainsworth.
Thank you. You guys have a good one. Good job today. Proud of you guys. Okay. Yes, Kaylee.
So I have a question. So I didn't know for my assignments that I turned in for 7A2, they've been like mixing up, and I guess I've been putting in the wrong assignment for that because I've been checking to make sure, because the drive where I save all my files have been like messing it up. So I have that all done and I'll turn it in and I'll resubmit the actual correct assignment for those.
Good, because I'm going to be getting caught up on grading all the assignments today and tomorrow. So as you submit, I'll see that, and if I see multiple submissions, I'll look at all of them and just make sure it's all good.
Okay, thank you. And I watched 7A3 prep already, so I was just wanting to make sure because I didn't know if that was going to be correct. But for one of the examples that we did, I don't know which one that was. It was like the one where it goes -2, 3 to 4, 3. I was wondering if for like the range, because it's so fixed, would you put like in the little brackets like -2 is less than equal to X less than equal to 4?
Okay, which one are you talking about here first? The 783. On which example are you talking about?
This one, the one where it's like a small little bracket.
Okay, so a horizontal line segment.
Yeah,
That's
the one we just did in class.
but are you talking about this prep right here, 7A3?
Well, no. For one of the examples for 7A12 that we went over in class today, for one of the examples you did, I was thinking of it in the 7A3 kind of way because I watched it already, and
Okay.
I was just wondering if like my way of thinking for the range was correct.
Okay, let me see it again. I'm sorry. Okay.
You're fine.
So -2 to 4, good. Y = 3. Okay, on the range, you could just say Y = 3, and you don't have to specify that the interval or the inequality right there. You can just say Y = 3 because it's constant.
Oh, okay, so it wouldn't matter if like I put that in there because it's so short.
No, it's just that when you specify the range, it's just the Y values that you're describing, and you're not trying to describe the X values. That was done in the previous domain.
Okay.
But
Okay.
your range of Y = 3 is fine. And
Okay.
the one above it, the domain that you wrote down, is fine too.
Okay. Thank you.
You're welcome. All right, I'll see you soon, okay?
Bye.
Bye-bye. Ariana,
Hi, how are you?
doing all right. How are you doing?
I'm doing good. I was just gonna ask about if I should start the next section from last semester.
What is that next? I've got to refresh on my memory and where we are at, and holy cow, what we did. So
I
what was the
think
last?
I
What
think
was
the
the last
last one
test you
was
took?
section 3. I'm pretty sure.
So let me see if I can bring that up here. Yeah, so you did section 2 and section 3. Do you have to redo? What else do we have to do in section or first semester?
I think just the final.
You blew the final. Let me go back and let me look at the grades here. Hang on. Give me a second here. I have to bring it up.
Okay.
How'd you do today in terms of your understanding?
Yeah, I forgot to complete the assignment yesterday, so I still have to work on that. So I'm gonna do that after this.
Okay. Are you talking about 7A2?
Yeah.
Okay. Well, getting caught up would be good. And again, look for the video resources in there. Go in each page in Canvas and take a look at it because I put up a lot of good stuff in there for you.
Okay.
That will help you. Okay. Let me see. I'm looking at your grades now. I just have to look at everything. Yeah. Okay. So section 3, section 2. Hang on, I just got to find the final grade here.
We're good.
Yes. Okay. You struggled on the final, which makes sense because you obviously were struggling overall. But all right. So let's do this. That was the multiple. Well, there was two parts. The multiple choice final. So we need to pick a day where you have like 2 hours of free time, and it's not today because you have to get caught up on your material and get ready for Friday. So maybe over the weekend or something. Do you have, what's your weekend looking like?
I think I'm pretty so far. Yeah, I don't think I have anything this weekend.
Because I can open it up this weekend and give you another shot at it. You will have to prep. Now you have the final review materials still, I hope. Right?
Yeah, I still have them.
You're gonna have to practice a little bit. You're gonna have to review because if you go in and try to take this test without reviewing, because it's been a couple weeks since you've done section 3, I would suggest you're gonna have to review. So maybe review on Saturday, put a couple hours in, and then take the test on Sunday. What do you
Yeah,
think?
that works.
What time Sunday do you prefer?
Maybe like 10, like 10 to 12 would probably
Okay,
work.
get your calendar out and write it down.
Okay.
Okay, I'm gonna write it down too because I have to go into Canvas and reissue that. So Sunday, well, write down Saturday. You're gonna do first semester final review. Plan at least 2 to 3 hours of doing that. You gotta make that happen and do it in the morning. Set a goal like, okay, I'm gonna review from 10 to 12 on Saturday. And then, I'm not going to goof around. I'm not going to play on my phone or the computer or anywhere. I'm going to review.
Yeah.
And then write down Sunday from 10 a.m. to 12 p.m. You're going to do the final. Sound good?
Yeah, I got it. Thank you.
Okay. And I'll have to get that set up for you. And then if you have any questions or if you need a, you know how to get a hold of me through Remind. So I'll make sure I'll set a reminder on my phone that you're testing on Sunday, and I'll keep track of my phone just in case you have an issue.
Okay. Sounds good.
All right.
All right.
I have no idea what I'm doing on Sunday right at this moment. But I'll try to make myself available just in case you need me.
Okay. Okay, cool. Thank you.
Anything else I can help you with?
Not right now. I'm just gonna start on the assignment from yesterday and hopefully it makes sense. If not, then I'll just text you.
You can always meet up if you do it now. Well, actually, wait a minute. You have another class coming up. Well, the last class starts at 10:55. It's 10:30. Yeah, you don't have time to do the video well, you can start it. But if you need me later in the afternoon, you can always see me in intervention if you need me.
Okay, sounds good.
All right. Well, have a good day and I'll see you soon.
All right, thank you, you too.
All righty. Bye-bye.